Okay, so now we've got the second half of the GCSE video for the higher paper. So this one we've got to find out the class interval, which is either going to be this one or this one or this one, so on and so forth, where the median lies. Now we've got 60 days. So if we take the median of that, I mean, we could add 1 divided by 2, or we could just simply divide it by 2. So I want to know where the 30th piece of data lies. Now here, we know that the first 7 pieces of data lie here. So that's going to be piece of data 1, 2, 3, all the way up to 7. Then the next 9 are going to lie in this one. So if the first 7 lie in this one, that's going to be the 8th, the 9th, the 10th, the 11th, 12th, 13th, 14th, 15th, and the 16th. If we add these two up, that makes 16. So that's the first 16 pieces of data lie here. Then the next 16 pieces of data lie in this category, or in this class interval. So that's going to be these are the 7th, then that's up to the 16th. That's going to be the 17th, 18th, and then the next 16 pieces of data. So that's going to be up to and including the 32nd piece of data. So if we're looking for the location of the 30th one, which is the middle one, or the median, then that's going to lie here, because the 30th, 31st, and 32nd are all going to lie in this one here. So the class interval is going to be 18 to 21. Okay, so now we've got to find an estimate for the mean. So the estimate for the mean, we've got to find the midpoint. So the midpoint of 10 and 13 is going to be, if you don't know how to find the midpoint, do 10, especially because we've got a calculator, 10 plus 13 divided by 2. Or we can see that the gap, and that makes 11.5. Or we can see that the gap is 3 between 10 and 13. So just add half that gap on and we get 11.5. So the first thing we're going to do is find the midpoint. So 11.5, 15.5, 19.5, 23.5 and 27.5. And then what we've got to do then is, just like we did beforehand, we multiply in the last question, multiply these together. And then we work out what all the totals are. So 11.5 times 7 gives us 80.5. 15.5 times by 9 is 139.5. 19.5 times by 16 gives us 312. 23.5 times by 22 gives us 517. 27.5 times by 6 is 165. And then once we've done that, we add them all up. So we do 165 plus 517 plus 312 plus 139.5 plus 80.5, and that gives a total of 1,214. Then we add the frequency up, which we should get 60 because they tell us there that it's 60. And then we do 1,214 divided by 60, and we get 20.2 and 3 recurring. And so we see whether or not this is a likely answer. So hopefully it'll be somewhere in the middle. So if we have a look in the middle of our data here, the middle is going to be around about here. So 20.23 lies roughly in the middle of that. So yeah, we're quite confident that's the correct answer. And now we're going to do a frequency polygon for this. Now, frequency polygon, all that is that's a line graph which sort of goes up and down like this. And what we have to do is we have to plot the midpoint. Plot the midpoint against the frequency. So that's going to be 11.5 plotted against 7. It's going to be 15.5 plotted against 9. 19.5 plotted against 16. 23.5 against 22. I mean, this is really, really easy, but people forget that it's called a frequency polygon. 27.5 against 6. So again, that is why we're doing revision. And so we put 11.5, so 11 is going to be here, 11.5 is going to be halfway between 11 and 12, and 7. So we can see here it's not going to be 5, 6, 7, because it doesn't go 5, 6, 7, 8, 9, 10. So it must be going up 2 squares for every 1. So just be careful of this. So 11.5 will be roughly here, then go up to 7, so that's 5, 6, 7, and that's going to be there. Then we've got 15.5 and 9, so 15.5 and up to 9. We've got 19.5 and 16. So that's 16, which is there. 23.5 and 22. So 23 is 23.5 and 22 is there. And 27.5 and 6. It's going to be there. And then what we do is we join them up like a dot to dot. Frequency polygons are very, very easy, as long as we just do the dot to dot like this. There, 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 and there. Very easy marks, but so many people don't get them because they just don't remember what a frequency polygon is, and they do a bar graph. So make sure you don't do a bar graph. So again, make a note of it. Frequency polygon is a dot to dot where you join the midpoints. Okay, trial and improvement, one of my favourite types of questions. So what we do is whenever we see a trial and improvement question, we do ourselves a table. And in that table, we write x, we write x cubed minus 2x, and then we write big or small. So we've got to try and find a value of x to one decimal place that makes 7. So let's try 1 first and see what we get. So we do 1 cubed, take it, that's 1 times 1 times 1, take away 2x, let's take away 2 lots of 1. So we just substitute 1 into here, so that's going to be 1 cubed, take away 2 lots of 1. And if we substitute 1 into that, we get minus 1, and we want 7, so that's far too small. So let's try 2, substitute 2 into that. And we get 4, which again is too small. So we try 3. And that's 21, which is too big. Okay, so now we've got a trap between 2 and 3. So then we try 2.5. So we put 2.5 in there, and if we do this, we get 10.625, which is slightly too big, but it's getting closer. So we try. So if 2.5 is too big, let's try 2.3. And if we substitute 2.3 in, we get 7.567, which is just a little bit too big because we're after 7. So try 2.2. 2.2. And if we do that, we get 6.248. So we know that 2.3 is too big, 2.2 is too small. But what we do have now is we've got 2 marks. We've got a trap between these 2 values here. Once we've got a trap between those 2 values there, even though it says only to 1 decimal place, we try the number that's halfway between it. And the reason that we do that is if we do it on a diagram here, we know 2.2 is too small and 2.3 is too big. But we know our answer lies somewhere between it. So our answer lies somewhere in this field here. So what we're going to do is we're going to find the midpoint, so 2.35, and we're going to test that one. So if we do 2.35, we end up getting, so 2.35 gives us 8.277875, which is too big. So this one tells us it's too big. So if this one is too big, it means that our answer must lie in this bit. And if our answer lies in this bit, it's going to be closer to 2.2. So we end up writing x equals 2.2. So just quickly go through it, because that's a lot of information there. So step 1, what we do is we do the table, and then we find a number that it's trapped between. So a lot of the time they give it to us, but we found out by doing it there's trapped between 2 and 3. Once we've got a trap between 2 and 3, what we need to do is get a trap between 1 decimal place, so 2.3 and 2.2. So that was our first mark. Our second mark was for getting a trap between 2.3 and 2.2. Our third mark, which a lot of people forget, is to then try it. Once we've got a trap between 2.3 and 2.2, we try halfway, which is 2.35. And once we've done that, once we've got our 2 decimal places, if it's too big, we go for the smaller one. If it was too small, we'd go for the bigger one. In this case, our one was too big, so we went for the smaller one, so x is 2.2. quite a nice question to get 4 marks for that one. Okay, so weight and proportions. So what weight of vegetables, sorry, is needed to make vegetable soup for 3 people? Now this makes it for 4 people. So if I know that 4 people serves this, let's do a quick recipe for 1 person. So what we're going to do is find a quarter of the recipe. So that's going to be 150 grams. It's going to be 100 mils. It's going to, if we do 3 divided by 4, it's just 3/4. 2 divided by 4 is going to be 1/2. So that's what we need for 1 person. So for 3 people, we need 3 lots of it. So we're just looking for the vegetables. So if 1 person is 150 grams, 3 lots of that is going to be 3 lots of 150 grams, which equals 450 grams of vegetables. How many tablespoons of oil is needed to make 6 people? So with the, okay, so if this is for 4 people, if we do the recipe for 2 people, because if we do that, we can add 4 people and 2 people together to get the 6 people. So we need to know the recipe for oil for 2 people. So it's 3 tablespoons. So if 2 people is going to be half that, it's going to be 1.5 tablespoons. So then if you add this one to this one, that's going to be 4.5 TBLS tablespoons. And that's what we need. Okay, Matt has only 1 litre of stock. He has plenty of other ingredients. What's the maximum number of people he can make vegetable soup for? So let's have a look at this one. So he's only got 1 litre of stock. So we know that 8 people is going to be 800 mils. Okay, so we can make it for 800 because he's got enough stock. If we carry on the recipe for 2 people here for stock, then 2 people is going to be half of the stock, so that's going to be 200 mils. So if we add 200 mils to 800 mils, that's going to be adding 8 people to 2 people, so that's going to be 10 people. So that's that question there. Question 27. So we know that AD is X, and we know that BC is the same length as that, so that's going to be X as well. AB is twice the length of AD, sorry. So this one is 2 lots of this one, so that's going to be 2x. And DC is 4 centimeters longer than AB, so this is going to be AB, which is 2x, and then add 4. Now we're told that the perimeter is 38. So this is one of those algebra questions where you've got to construct it yourself. Now if it tells you the perimeter, I mean, all the way through school from primary school, you know the perimeter is all the way around the outside. So if we add up all the way around the outside, that's going to be x plus 2x plus x plus another 2x. That's going to be 1, 2, 3, 4, 5, 6 x's. Then we've got that plus 4. So that is what the perimeter is in terms of algebra. We're also told that it's 38 centimeters. So now we've got 6x plus 4 equals 38. So we've got to work out what x is. So if we take away the 4 from both sides, we've got 6x equals 34. So we've got to divide by 6. So x equals 34 over 6, which if we do that on the calculator, 34 divided by 6 equals 5 2/3, or 5.6 recurring. So the length AD is this one here, which we are told is x. So the answer is 5.6 recurring. Make sure you put the recurring thing above it, or write 5.67. Don't just write 5.6, that would be incorrect. Okay, next question. We've got to complete the table, and then we've got to draw the graph for this. So hopefully, oh, it's quite small. Let's see if we can make it a little bit bigger so we can see what's going on. Let's go 50%. Let's go 55%. Let's go 60%. Highlight of the video, right? Okay, so this we've got to draw the graph of 6, y equals 6 over x. So y equals 6 divided by x. So divided by 6 is 1. 6 divided by 5 is 1.2 on the calculator. 6 divided by 4 is 1.5, so that's how they're getting all these values. 6 divided by 3, you shouldn't need a calculator. It's 2. 6 divided by 0.5. Divided by just means how many times it go into it. So 0.5 goes into a whole one twice, so it's going to go into 6 whole ones 12 times. And then once we've got that, we simply just plot it, just like any other graph. So 0.512 is going to be that point there. 1, 6 is going to be that point there. 2, 3 is this one. 3, 2 is this one. 4, 1.5 is that one. 5, 1.2 is there. And 6, 1 is here. Remember that this isn't 1.1, 1.2, 1.3, 1.4, and then 2. It's going up in 0.2. So it's 1.2, 1.4, 1.6, 1.8, and then 2. Right, what you must make sure you do afterwards, because for some reason people forget to do this all the time, you must join the points together to make a nice smooth curve. And that smooth curve is what you need to get the final mark. Okay, I think we can afford to make this a little bit bigger now. So triangle P is drawn on the coordinate grid. Triangle P is reflecting the line x equals -1. So the line x equals -1 is simply, this should say x-axis and this should say y-axis. So the line x equals -1 is simply a line that goes through the x-axis at -1. And then when we reflect, we've got 1, 2, 3 things to reflect. So this point up here is 2 away from the line of reflection. So go to the other side, and we've got it there. This point here is 2 away, so go to the other side, and that's there. This point here is 1, 2, 3, 4 away from the line of reflection. So 1, 2, 3, 4 the other side, and we get there. And then we join it up. And that's P reflected. So it's been reflected in this line, and then it's reflected in the line y equals 1. So now we draw the line y equals 1. So that's just a line that goes through the y-axis at 1. Very, very simple. But something, again, that a lot of people forget. So we reflect it in the line y equals 1. And so this point here is 1 away, so we go 1 the other side. This is 1 away, so it's 1 the other side. This one here is 1, 2, 3, 4, 5 away. So 1, 2, 3, 4, 5 away down here gives us this here. And then we call that Q. Now what we've got is we've got to fully describe the single transformation. I'm going to underline the word single 4 or 5 times because that just means one thing has happened to P to get onto Q. So it's not been translated, it's not been picked up and moved, it's not been made bigger. It's been reflected twice, but that's not a single transformation. So what's happened between P and Q? It's been rotated. So you get 1 mark for saying that it's been rotated. The angle it's been rotated through is 180 degrees. And then you've got to find the point of rotation. Now you should have some tracing paper when you do your exam, so it might be a case of just putting tracing paper over the shape here, and then try and put your pen in different points until it gets rotated onto this shape here. And if you do that, you should end up at this point here. So what you need to say as your final mark is been rotated 180 degrees, and the point of rotation is point -1, 1. And that is the point of rotation. Rotation. Okay. Okay, so continuing on with this, question 30. And we've got to enlarge a shaded triangle by a scale factor of 1/2 with the centre -3,3. So the first thing we need to do is we need to write down or find out where -3,3 is and mark it. So that's what we're going to call the centre of enlargement. Now this triangle here has 3 points, and we've got to enlarge all of those points with a scale factor of 1/2. Okay, now this isn't a straightforward straightforward enlargement because it's got a scale factor of 1/2, but it's pretty simple because all you have to do is just count. So what we do all the time, we start off with our centre of enlargement here, and to get from our centre of enlargement to our first point, we've got to go 1, 2, 3, 4 to the right. So the scale factor of 1/2 just tells us what to do. We've got to do half of that. So instead of going to the right by 4, we go to the right by 2. So we go back to our centre and we count 1, 2, which which is there. Right, now to get from our centre of enlargement, again, going back to our centre of enlargement each time. To get from our centre to this point here, we go to the right 1, 2, 3, 4. So we go to the right by 4, and then we go down by 1, 2, 3, 4, down by 4. So the scale factor of a half means that we're going to half that. So instead, we go right by 2 and then down by 2. So go back to our centre of enlargement, right by 2, down by 2, and we get to this point here. This one, we go to the right by 1, 2, 3, 4, 5, 6. So we go right by 6, then we go down by 1, 2, 3, 4. And then we do half of that. So that's going to go right by 3, down by 2. So 1, 2, 3, and down by 2, and we get to this point here. Join them up, and that is our shape halved, or enlarged, by a scale factor of a half. So again, another reason that people don't get this right is because they assume enlarge means to make bigger, but enlarge can actually mean make smaller. Enlarge just means change the size of the shape. Okay, so that's question 30 done. Question 31, and it looks like here, just by looking at it, even before we read any of the question, we've got a right-angled triangle here. And we've got 19 meters there, and we've got an angle. So before I even read the question, I'm thinking it's going to be a trig question. So a man is working out the height of a vertical tree. The man is able to measure the angle of elevation of the top of the tree from his measuring instrument. So bear in mind that the measurement instrument starts here. The measurement instrument is 1.8 meters above ground level. When the man is standing 19 meters from the base of the tree, the angle he measures is 56 degrees. A sketch of the situation is shown below. Calculate the full height of the tree. Well, the first thing we're going to do is we're going to calculate this part of the tree here, which isn't the whole tree. So we're going to use trigonometry to figure out what this height is here, and then we're going to add on this bottom bit, which is going to be 1.8. So if we just do a real basic sketch of what we've got 56 degrees, we've got this, which is 19 meters, and we want to work out the height, which is that one. So in this question, the first thing we do with trig questions is we label the sides. So the hypotenuse is going to be this one, but we're not going to write that one down because it's blank. We're not looking for that one in the question. What we're looking for is this one here, which is the opposite, and we've already been given this one here, which is the adjacent. So we've got to think from the SOHCAHTOA what involves both O and A. And as my year 9 have just told me, it is TOA. So well done to those guys. Okay, now in this question, we are looking for this side here, which is O. So what we do is we cover up the side that we're looking for. So we cover up O, and we're left with T times by A. Now the reason that it's times is because they're on the same side, so the same level, they're both on the bottom. So it's going to be T times A. So I'm going to write down that the opposite equals T, which means tan. That's going to be tan and tan of the angle, which is 56. Remember, the bottom left-hand corner always relates to the angle. So tan 56 times by the adjacent, which is 19. So we then type it into our calculator. So we do tan 56. And if you do tan 56, make sure either the 56 in brackets or you press tan 56 and then equals. And then you times by 19. So you get 28.168, which you then have to, so 28.168. Then you need to add on this 1.8 meters. So we add on 1.8, and we get 29.968 meters. It doesn't say to any degree of accuracy, so I'd probably leave it like that. In fact, sorry, that should be 969 once we do the round. Just be careful of any rounding. Okay, next question is question 32. And we've got to calculate length CD. So what we've got here, if I use a different colour, might be easier. We've got to work out the length of a slope. Now, we've got a right-angled triangle here. We've got to work out the length of a slope. So it's either going to be Pythagoras or trigonometry. So what we've got is we've got 40 degrees, And we've got to work out this one, but we've got no other information. So we need some more information in order to use trigonometry here. So what we are given, though, is we're given that this is a right angled triangle here, and we've got 12 and 16. So if we've got a right angled triangle, this one is 12 and this one is 16. We've got no angle there, but if we want to work out the third side of the triangle, we use Pythagoras. So we know that the longer side is always going to be c. So if we do a squared plus b squared equals c squared, then we write in the information that we know. So 12 squared is going to be 144. B squared we don't know, so we still keep it there. C squared is going to be 16 times 16, which is 256. So now, if we've got to find one of the shorter sides in Pythagoras, we take away. So it's going to be b squared as 256, take away 144, which is 112. Then to figure out what b is, we do the square root of 112, which gives us 10.58. So this is 10.58, which means that this side here is 10.58, which if we go back to our original diagram means this is 10.58 centimeters. And so now what we've got is we've got a trigonometry question which we first thought it was going to be, but this time we've also got another side. So we've got this one, which is the opposite. We are looking for the sloping side, which is the hypotenuse, and we've got to decide which trig we use when we've got O and H. So if I ask my year 9s again, what do we use for O and H? So, yeah, thank you. So, thank you, Raf. So, we need, if we use SOH here, we need to find the hypotenuse. So the hypotenuse, we cover it up. And if we cover up the hypotenuse, we've got O divided by S left. So that's what I'm going to write down, that the hypotenuse equals the opposite divided by S, which is sin of the angle, so sin of 40 degrees. So in my calculator, I'll do 10.58 divided by sin 40. So 10.58 divided by sin 40. And by doing so, I get 16 point, if I round to three significant figures, 16.5 centimeters. So that's how you do that question there. Right, not many questions left to go. Okay, so Alicia is planning a party, and she wants to buy some cakes and sausage rolls. Well, who wouldn't? That sounds like some party. The cakes are sold in boxes, and there are 12 cakes in each box. Each box costs £2.50. The sausage rolls are sold in packs. There are 8 sausage rolls in a pack. Each pack of sausage rolls costs £1.20. Lisa wants to buy more than 60 cakes and more than 60 sausage rolls. She wants to buy exactly the same number of cakes as sausage rolls. So what we need to do is we need to find a number where 12 and 8 both go into, because she wants the same amount. So she wants to buy exactly the same number, but it needs to be more than 60. So if we have a look at the cakes, 12, 24, 36, 48, 60, 72, 84, 96. Now let's try the sausage rolls. So it's going to be 8, 16, 24. Now 24 lies in both of them, but it's not more than 60. So 24, 32, 40, 48, 56, 64, 72. Now we stop at 72 because 72 lies in both of them. 72 is more than 60, and it's what they both go into. So what that means is that we need to buy, how many boxes of cakes? We need to buy 1, 2, 3, 4, 5, 6 boxes of cakes. So we need to do 6 boxes of cakes at £2.50 each. We're going to need to add to that 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes of sausage rolls, and the sausage rolls cost £1.20. So the total bill is going to be 6 lots of the £2.50 plus 9 lots of the £1.20. So just make sure I don't make any mistakes. 6 lots of £2.50 is going to be £15. 9 lots of £1.20 is going to be £10.80. So we add that together, so we end up getting £25.80. And that's that. Question 34. Okay, next question. Rectangle ABCD is mathematically similar to rectangle DAEF. Now, what you need to know is that mathematically similar means it's going to be an enlargement. And on all these mathematically similar questions, I tend to draw out both the smaller shape and the enlarged shape. So the smaller shape, you've got a rectangle which looks like this, where the longest side is 10, and where the longest side is 4. And then if I switch a bigger one round, I've got a bigger rectangle where the longest side is 10 and the smaller side is 4. So if they're mathematically similar, it means that there's going to be a scale factor. So it means that this one times by something equals this one. So 4 times by something is 10. So the way to work that out is we do 10 divided by 4. So we do the equivalent sides divided. That equals 2.5. So therefore the scale factor is 2.5. So it means I need to multiply everything here by 2.5, and that gives me this one here. If I'm going to go around the other side, the other way, I'm going to need to divide by 2.5. So if I do 4 divided by 2.5, it means that this one here is going to be 1.6. So going back to the diagram up here, it means that this here is going to be 1.6. And we've got to work out the area of rectangle DAEF. So we've got to work out this rectangle here. So we need to multiply 4 by 1.6. So 4 times 1.6 is 6.4 centimetres squared. The key thing here, and the key thing to remember when you're doing your revision, is that mathematically similar means that it's going to be an enlargement, and the first thing we need to do is we need to work out what the scale factor is. And I think the easiest way to do that is to draw out the diagram of the smaller shape and the similar enlarged shape. And then from there we go on and find the scale factor, then that helps out by finding out all the other information that we need. Okay, histogram questions. Now, histograms, the main thing to remember is that the area of the bars equals the frequency, or the number of people in this question. So what we're going to do, if it says calculate the number of people in the group, we're going to work out the area of all the bars. Now, the first bar here is 30 times by the height, which is 0.2. So if we do 30 times 0.2, 30 times by 0.2, we get 6. So there's going to be 6 people there. Next, we've got a width of 10 and a height of 0.4. So 10 times by 0.4 is 4. So that bar represents 4 people. Next one, we've got 10 times by 0.8. So 10 times 0.8 is going to be 8. Next one, we've got 10 times by 1.2. So 10 times by 1.2 equals 12. Again, we've got a width of 10, and the height is 1. So 10 times by 1 is going to be 10. Finally, we've got a width here of 30, and a height, if we track across, of 0.1. So 10 times by 0.1 is going to be, oh, sorry, it's not 10, is it? That's 30, the gap of 30, so 30 times by 0.1, and that equals 3. So we've got to calculate the number of people in the group, so that's going to be all of these added together. So 6 plus 4 is 10, plus 8 is 18, plus 12 is 30, 40, 43. So there are 43 people in this group. And we've got to calculate an estimate for the number of people who answered the phone in less than 65 seconds. Okay, so less than 65 seconds, that's going to be all of these people here, because they answered it in 30, all these people here, all of these people here, all of these people here, and 65 is going to be half of this. So what we can do is we work out the area of this bar here. So that's going to be 5 times by the height, so 5 times 1, so that's going to be 5. So then we add up all the other bars. That's going to be 6, 4, 8, 12, and 5. So 6 plus 4 is 10, plus 8 is 18, plus 12 is 30, plus 5 is going to be 35. So when we do this answer, that's going to be 35 people who answered the call in less than 65 seconds. So the way we do that is we simply go across 65 and then read up. Okay, now here we've got a cumulative frequency table. Now usually they ask you to do the cumulative frequency graph. They've already given you the cumulative frequency here. Now cumulative frequency, we usually add up the first one, and then this one plus the next one, so that'd be 95, plus the next one, so that'd be 95 plus 138, but we don't do that in this question. Sorry if that's confusing, but because they've already given us these answers here, and this is once they've done that process before. And so what you do is you need to multiply this, so we don't multiply, sorry, we plot this point against this point. So we always put the cumulative frequency in a circle, and we also circle the upper boundary. So 138 and 40. Now I'm going to write them over here so I can plot them in a second. So 20, 30, 40, 50, 60, 70, and 80. That's 25, 70, 138, 175, 186, 194, and 200. So I'm going to need to make this a little bit smaller. Okay, so let's try 60%. Okay, yeah. So once we've circled the cumulative frequency and oh god, what was that? That was 25. Okay, so once we've circled the 25 and the 20, the 70 and the 30 and so on and so forth, we then go on to this and then we plot them. So across 20 and then up by 25. The next one we plot is 30 across and then 70. So 30 across and then 70 up. Then we've got 40 across and 138 up. And then 50 across and 175 up. 60 across and then 186 up. Again, if 180 is here, you need to go up 1, 2, 3, because these are going up in 0.2s each, or 2s each time. No, they're not. Sorry, my mistake. 186 there. And then 70 and then 194. And then 80 and then 200. And once you've done that, you join them up with a nice smooth curve, which is called an ogive curve. Hopefully yours should be a lot smoother than that. Now, they then said afterwards, Graham says 10% of workers are older than 65. So 10% of 200, so here we've got 200. So 10% of 200 is 20. So I want to know whether or not 20 people were older than 65. So what we do is we go up from 65, and then we read across. And if we do that, that's about 172. So therefore, up to 200, so 172 up to 200, that's going to be 28 people. So we said 10% are older, so we said there's at least 20 people are older than 65, and we found out that 28 people are older. So yeah, he's right, at least 10 people are older. And that's it. That is the final question. Okay, best of luck, boys and girls. If you have any questions, please leave them in the comments box, and I'll endeavour to get back to you as soon as possible. But thank you. Like and subscribe.